All right, sixth graders, well, we're getting on into this here. It says, tell whether the given value is a solution of the equation. So we're moving on here. This is lesson 6.2. And you're going to look at a problem like this. For example, it says, x plus 37 equals 70. And then it says, well, x equals 43. So all we're going to do is plug in 43 for x. And we're going to come over here and do 43 plus 37. Well, 3 plus 7 is 10. Put the 0 down, carry the 1. 1 plus 4 is 5, plus 3 is 8. I get 80. Well, x plus 37 does not equal 80. It says it equals 70. So x cannot equal 43, which means that's a no. And that's all you write is yes or no. So here I have this one, 9x equals 72 if x equals 8. Well, remember that a number right next to a variable means multiplication. So if x equals 8, this is going to be 9 times 8. And sure enough, 9 times 8 does equal 72. So this second one here is most definitely a yes. Moving on to this one, x minus 23 equals 46, x equals 69. Well, that means that I'm going to do 69 minus 23 because I'm going to plug in 69 for x. So if I come over here and I do 69 minus 23, 9 minus 3 is 6, 6 minus 2 is 4, I get 46. And sure enough, x minus 23 equals 46 when x equals 69. 69 minus 23 equals 46. So this one is also a yes. This one here, x over 7 equals 49 when x equals 7. Well, this is 7 divided by 7. That's what a fraction is. A fraction is division. 7 divided by 7. Well, what does 7 divided by 7 equal? 7 divided by 7 equals 1. This is not a multiplication problem where we're doing 7 times 7. This is a division problem. 7 divided by 7. 7 divided by 7 equals 1. This is most definitely a no. Last one in this section, 19 minus x equals 2. And it says x equals 17. So I'm going to plug in here 19 minus 17. Well, 19 minus 17, 9 minus 7 is 2. 1 minus 1 is nothing. So I get 2. Well, sure enough, 19 minus 17, if x equals 17, equals 2. This one is a yes. All right, moving right along to the next part here. This next part, you're going to focus on this phrase, isolate the variable. This is a phrase you're going to hear. You're going to hear it quite a bit in the next video for 6.3 as well. Isolate the variable. Well, when we put something in isolation, when we isolate something, we put it by itself, okay? And when I want to solve an equation, I want to isolate the variable. Well, the variable here is x. X plus 19 equals 86. I want to get x by itself. I get x by itself by getting rid of this plus 19 by subtracting 19. That gives me 0. But if I subtract 19 from this side, I also have to subtract 19 from that side. I can't do 6 minus 9. Cross off the 8, make it a 7. Make the 6 a 16. I do 16 minus 9, and that's 7. 7 minus 1 is 6. And sure enough, I find that x equals 67. And sure enough, if I were to check, 67 plus 19 would equal 86. So I go to this next one, x minus 7/8 equals 3/4. Well, since this is technically a negative 7/8, what I'm going to do to get to 0 is add 7/8, and that's going to give me 0. That's going to give me x by itself. But if I add 7/8 to this side, I've got to add 7/8 over here too. So it becomes 3/4 plus 7/8. And we need to remember our rules of fraction addition. I've got to find a common denominator. And with 4 and 8, I think the common denominator is going to be 8. That's going to stay 7/8. It was 4 times 2, which gave me 8. So it's got to be 3 times 2. That gives me 6. 6/8 plus 7/8 equals 13/8. As a 6th grader, first of all, you should know that 13/8 is in simplest form because the only number that can go into both 13 and 8 is 1. But you should also realize that that can be turned into a mixed number because 13 is bigger than 8. And sure enough, when I do that, 8 can go into 13 one time. If I take 8 into 13 one time, I think I'll have 5 left over. My denominator here is 8, which means my denominator here is 8. I end up with 1 5/8. Final answer. All right, 3 and 27/100 plus x equals 58. Well, here the x is over here, but it doesn't really matter. Still, what I have to get rid of is this 3 and 27/100. And since that's a positive 3 and 27/100, I'm going to subtract 3 and 27/100 from this side, which means I have to subtract 3 and 27/100 from this side. So it's going to be 5.8 minus 3 and 27/100. Now, as I know, I can't just drop the 7. As we've talked about before with subtracting decimals, I've got to put that 0 there. All right, I can't do 0 minus 7, so I'm going to borrow from the 8, make that a 7, make that 0 a 10. 10 minus 7 is 3. 7 minus 2 is 5. Dropping the decimal straight down, 5 minus 3 is 2. I get 2 and 53/100. X equals 2 and 53/100. And you're just doing with these one-step equations. We've got a couple more to look at. 32 equals x plus 27. Okay, once again, I want to isolate x. It doesn't matter what side x is on. I still want to isolate it. Now, this is a positive 27, so I'm going to subtract 27 and make it 0. And since I subtracted 27 from this side, I'm going to subtract 27 from that side. Okay? And I can't do 2 minus 7, so I'm going to borrow from the 3, make it a 2, make that 2 a 12. 12 minus 7 is 5. 2 minus 2 is nothing. I find, sure enough, that x equals 5. And if I check that, I see that works because 5 plus 27 does indeed equal 32. All right, last one for today. 3 and 1/4 equals x minus 2.5. Well, when I isolate the variable, this is a negative 2.5 or a minus 2.5, which means now that I need to add it to get to 0. So I'm always doing the opposite. You should notice that. When this number in the problem is a positive number, I'm subtracting it to get rid of it. When it's a negative number, I'm adding it to get rid of it. It's what gets me to 0. So negative 2.5 plus 2.5 is 0. So I'm going to come over here, and I'm going to have 3 and 1/4 plus 2.5. Well, if I'm looking for a common denominator, I think that's going to be 4. So I think my 3 and 1/4 is just going to stay the same. This is going to become 2 and something over 4. I did 2 times 2 to get 4. So it's going to be 1 times 2 to get 2. Well, now I've got 1/4 plus 2/4. That's 3/4. Then I do 3 plus 2. That's 5. And I think that that is in simplest form because nothing besides 1 can go into both 3 and 4. I end up with 5 3/4. That's what we're doing today in lesson 6.3. We'll talk to you later, 6th grade. Bye.